there are lots of benefits to a black hole. It produces clean energy. If you just throw trash into it, you get pure energy in return.
Wow. So could we, if there was a black hole near enough to Earth, obviously we've got a huge issue with global warming and pollution, could we essentially just chuck all our litter into the black hole and then all of a sudden get clean energy?
Yes.
Welcome back, everybody, to the podcast. And welcome back to, honestly, one of the single most incredible conversations I've had. This honestly broke my brain in so many different ways. Avi Loeb is an astronomer, astrophysicist, and also cosmologist at Harvard. In this conversation, we discuss everything from extraterrestrial life and what his thoughts are on extraterrestrial life. Have we been visited already? We discuss the complexity of black holes, and we discuss the fact that depending on where you're situated when you work in a building, if you're at the top or the bottom, you actually age slower or faster depending on where you're positioned. Honestly, it just broke my brain. This is the Into the Mind podcast, and my name is Harrison Brown. And without further ado, enjoy this episode. Where I wanted to start, and where I think the audience members will want me to start as well, is in the stigma around talking about extraterrestrial life. I think as soon as you bring that up, people have this stigma in their mind where they go, oh, he must be crazy, he must be insane, don't listen to him. And I think the beauty of someone like Joe Rogan or Lex Fridman is that they kind of draw the attention to the unknown, such as the extraterrestrial. What are your kind of thoughts on that kind of stigma and why that's there?
Well, I think it's anti-scientific. I'm a scientist, and I am attending to evidence. That's the only way for us to learn something new. And many people have opinions. That's the easy path. You can have opinions on politics, obviously, but many people have opinions on scientific matters. And the question of whether we have a cosmic partner, some other sentient being in our cosmic neighborhood, is a scientific question. It's not a political question. It's not a religious question. In fact, I attended a forum at the Harvard Law School yesterday with some spiritual leaders. They mentioned the fact that some religious people prefer not to believe that there is any extraterrestrial intelligence. And I said, well, I have 2 daughters, and the love that I give to one of them does not take away from the love that I give to the second one. So if there is God, you shouldn't expect God to have a lack of attention span just to attend to the sentient beings on Earth and not on any other exoplanet. And in fact, there are more Americans that believe in the existence of extraterrestrial intelligence than people that believe in the biblical God. So I told them, if you really want to expand your congregation, you might appeal to those. And so that's with respect to religious beliefs. But, a lot of people prefer not to speak about this subject. I think it's inappropriate because it will change the future of humanity if we find that there is intelligence beyond Earth. We could learn from a neighbor that is smarter than us. We could study new technologies because their science and technology may be, way ahead of what we developed in the last century. And in addition, it will change our perspective about the universe. When you look at the sky at night, it's dark and the universe appears to be lonely. And Steven Weinberg said, that the Nobel laureate said that the more we understand the universe, the more pointless it seems. He said that towards the end of his book, the first 3 minutes, I completely disagree with him. The reason the universe appears pointless is because we study elementary particles and radiation. But if we find intelligence beyond Earth, if we find a partner, it will have the same impact as finding a partner has in our private lives. It gives a meaning to our existence. The universe will not appear lonely. We might design a spacecraft that will aim to visit their home. We might develop our own science and technology with a quantum leap instead of us dedicating centuries to figure out how to unify quantum mechanics and gravity, they already know that. And we would see that in their technologies. By the way, what we know about the universe is just an island in an ocean of ignorance. All those quote-unquote experts or cosmologists who brag about our knowledge about in science, that is completely inappropriate because, we just do the accounting. We know which fraction of the mass budget in the cosmos is made of material that we are made of, the material that is familiar to us, but that's just only 5%. And the rest, 95%, is made of dark matter and dark energy. And so we don't even know what happened before the Big Bang. That's a major discrepancy in our knowledge about the cosmic history, about our cosmic roots. And so, we should give up on this notion of hubris, that things are centered on us. I think the default assumption should be that we were preceded by another civilization on another planet, because now we know that there are probably hundreds of billions of planets the size of the Earth in the Milky Way galaxy alone, and many of them are at the right distance to have liquid water on the surface. And I think it's arrogant to adopt the opposite assumption, which is that we are unique and special, and there is nothing like us. And since they didn't come to visit us and have lunch with us, they don't exist. Enrico Fermi asked, where is everybody? And this is a question that any lonely person asks. And what you tell a lonely person is, you should be proactive. Don't be so presumptuous as if you're so attractive that everyone will come to you. You need, at the very least, to look through the windows of your home, to look for partners, neighbors, or leave your home and go to dating sites. And Enrico Fermi didn't do that. He didn't construct a telescope to address his question. I'm doing that as part of my day job as an astronomer. So for people to dismiss the question, to argue that we don't have any extraordinary evidence, is really inappropriate. It's anti-science, because in order to find evidence, it doesn't fall into our lap. We need to invest a lot of time and effort. To search for dark matter, we invested billions of dollars over the past few decades. We haven't found anything. Now, if we were to invest billions of dollars in the search for technological signatures of other civilizations, and we hadn't found anything after several decades, we would be exactly at the same spot as the mainstream opinion about dark matter, which says there is indirect evidence for dark matter. We know about its existence from the laws of gravity as formulated by Einstein. And I say, well, how do you know that the laws of gravity are correct? Maybe they are violated at low accelerations. Until you find the particle, you don't know that. So for the mainstream to claim there is absolutely no doubt that dark matter exists, let's invest billions of dollars to search for it. While at the same time to say, oh, we are unique and special in terms of our intelligence, even though there are hundreds of billions of planets in the Milky Way galaxy, that's disingenuous. I mean, we should invest as much money, billions of dollars, in the search for technological signatures before we can say anything beyond what we are saying about dark matter.
Do you think it's a symptom, though? Do you think like the reason why we hear nothing about extraterrestrial beings and life and objects is a symptom of the government trying to cover it up? I mean, there's so much evidence that is coming out. And I think for example, Joe Rogan podcast has been brilliant for this because he highlights this evidence. And, there's pilots that have seen things in the air, like floating discs going up and down, maneuvering in ways that we can't fathom. And it seems to be pushed aside, pushed away. Do you think the government is they don't think we can they don't think we can come to terms with other beings being on our planet, and that's maybe why they're suppressing it a little bit?
No, I think the government is incompetent. It's not a scientific organization. If they see things that are unusual, first of all, it's not surprising because the U.S. spends almost $1 trillion on military expenses, and it's about a third of the world expenditure. And in the process of monitoring the sky, they might notice unusual things that astronomers do not notice because they're putting much more money into surveillance of the sky. And So you would expect the government to see things they don't understand, but you shouldn't expect them to figure out what these things are, because they are not a scientific organization and they are just focused on national security. That's their day job. My day job is to figure out what lies outside the solar system, and I very much hope they will share any interesting data with me. There will be a congressional hearing on unidentified anomalous phenomena next month, November 2025, and my hope is that more information will be revealed about the government data. But here is the important point, and I pointed this out in an essay that I posted this morning on medium.com. So you can actually check my essays on medium.com, Avi Loeb at medium.com. The one from today basically stated that forget about what the government knows about aliens. It is much more important what aliens know about the universe. If we knew what they know, if they are able to reach us at a much faster speed than our rockets, if they are able to use quantum gravity effects, our knowledge of that would be far more important. So, one approach is to press the government to release all the classified data they have. At the same time, since I'm not anticipating that coming out very soon, I'm leading the Galileo project at Harvard. We built a new observatory monitoring the sky 24/7 in the infrared, optical, radio, and audio. And we are about to release the first data paper about a million objects in the sky that we monitored so far in recent months. And we are building 2 additional observatories in 2 other locations. And these are not observatories that astronomers built in the past, because astronomers focus on a small portion of the sky usually. They might do a survey of the sky, but not at the same time the entire sky. So they might tile the sky. And there is actually an observatory called the Rubin Observatory about to be operational in 2025 that will survey the southern sky every 4 days with a 3.2 gigapixel camera. But what we are doing is look at the entire sky at all times, and that is quite different. And that was not done, scientifically speaking, for extended periods of time. People, military personnel just reported about the anecdotal events that they happened to be at the right place at the right time and saw things that are not easily understood. And I think it's the duty of scientists to clear it up.
Yeah, and I'd agree. I know you're releasing a paper. Was it tomorrow, you said, on the stuff that you've seen in the sky? Or was it?
Well, it should come out in the next couple of weeks. And I don't know exactly which day, but we are just finishing the final details in that paper.
And is there anything that you've seen so far that you can disclose that is an abnormal phenomenon?
No, we haven't yet seen an unidentified anomalous object that is definitely representing, something unfamiliar that is not human-made or natural. However, the Galileo project that I'm leading also retrieved materials from an expedition to the Pacific Ocean, where we went after the first interstellar meteor. That's an object that collided with Earth 2014 and was moving very fast, so fast that it was unbound to the sun. And in fact, it was moving faster than 95% of the stars near the sun. And It exploded only in the lower atmosphere. And that implied that it has a very high material strength, tougher than iron meteorites. So I was wondering whether it could be a Voyager-like meteor. And I led an expedition to the Pacific Ocean, to the site that was localized by US government satellites of the fireball, the explosion of this object. And we found some molten droplets that have a material composition different from solar system materials. However, these were very tiny, less than a millimeter in size. So we're planning to go again, hopefully next summer, to find bigger pieces of this meteor that will tell us clearly whether it was natural or artificial, and if so, how long was the journey, where did it come from, more information. It will cost $6.5 million. Currently, I'm in the process of seeking a potential funder for this expedition. But we have the ship, we have the tools that we want to use, a robot that will walk on the ocean floor, and we will have a video feed that will show us what we're picking up. So everything is available, including the research team. It's just the funding that we are waiting for.
And your primary objective there is to see whether a bigger piece of that is synthetic, or it could be deemed made by somebody, or natural. So if it is potentially made by not us, then the question arises, who's it made by?
Right. So think about dropping a laptop into a fireplace. If you just get the molten droplets from this gadget, you won't be able to tell that it's actually artificial. You will be able to tell the composition. But if you get a piece, you can say, oh, that's technological. And of course, if we find the core of the object, the original object, then we could see if it has buttons on it. And if it does, the question is, should we press a button?
Would you?
I personally would bring it to a laboratory and examine it before engaging with it. But I asked my class at Harvard this question, and half of it said, please don't press any button because it endangers all of us. And the other half said, please do, because we are curious to see what will happen. So, the vote was split.
It is interesting, though, to see how people would react to that kind of information. Like, I feel like, without getting into conspiracies, if the government are trying to suppress that knowledge of unidentified objects and of extraterrestrial activity, is it because they feel we aren't ready as a society to actually uncover that? Like, what do you think the knock-on effects would be of us figuring out that we aren't alone?
Yeah, well, we were not ready to the idea that we are not at the center of the universe, right? Aristotle said, of course, we are at the center. I mean, I can understand that because both my daughters, when they were young, they thought that the world centers on them until I took them to the kindergarten and they had a psychological shock when they realized that there are other kids just like them. So I can understand Aristotle in the spirit of my daughters. And people believed Aristotle for 1,000 years. And of course, the church used it in order to argue that God cares about us, that we are at the center of attention. When Nicolaus Copernicus came up with, he was a priest, by the way, and he wanted to help the church, and the church had a difficult time. In the model where the Earth was sitting at the center of the solar system, they couldn't forecast when Easter takes place. And so they had a problem. It was off by a few days. And Copernicus looked at the data and said, actually, if we put the sun in the middle, then everything works. And the church said, thank you so much for the theoretical model. We know that it's only theory. We will use it. But we know that in reality, the Earth is at the center. And they banned his book until the 19th century. Copernicus, on his deathbed, saw the first copy of his book, De Revolutionibus, which you can see on my left because I was invited by the Polish government to give a lecture celebrating 550 years to the birth of Nicolaus Copernicus. And my talk was about the next Copernican revolution, which is to say that we are not at the intellectual center of the universe. So my colleagues right now insist that the natural hypothesis is to argue that we are unique and special. I think it's arrogant. And I think we should search and put, billions of dollars towards the search before we can make even a statement about this question. And in the past, we looked for radio signals, but that's just like waiting for a phone call at home. Nobody may call you when you're listening. These radio waves move at the speed of light, and if they were sent a long time ago, they are now at the edge of the universe. However, objects like the rockets that we launch are moving too slow to escape from the Milky Way galaxy, and they accumulate in interstellar space, just like plastics in the ocean. So we could find space trash from other civilizations that predated us. And actually, most stars formed billions of years before the sun. And therefore, there should be enough time for those Voyager-like spacecraft to traverse the entire Milky Way galaxy and reach us. And we just need to look. We just need to search around us. And that's my point.
Do you think that it's possible that the meteorite that you're looking for, a bigger chunk of it almost, could be space junk that's floated, like it's been lost hundreds of years ago and then has come back towards us into our atmosphere, blown up into the ocean? Do you think it could be that, or are you quite set on the fact that it's not within our making?
Well, we don't know. I mean, it moved fast relative to Earth, and it's not bound to the sun. So unless it was propelled towards the Earth, if it was just junk, it would have escaped the solar system. Even if it was produced by another civilization that preceded us in the solar system, it would have escaped. So it could be space trash from a civilization far away. It could also be a rock that was naturally produced with these unusual properties in a process that is quite different from the rocks in the solar system. That by itself is also interesting. I'm not saying necessarily that we are the first intelligent or technological civilization in the solar system. It's possible that there was another one before us, and if it was hundreds of millions of years ago, which, by the way, is only 5% of the history of the Earth. I mean, it's you can imagine why not have a technological civilization like us when the Earth was 95% of its current age. I mean, nothing rules this out. And in fact, there is even evidence that 252 million years ago, there was global warming with all the signatures of the global warming that we are witnessing right now. And it was very sudden, very abrupt, perhaps shorter than 10,000 years in duration. And it's not clear exactly what triggered that. But at any event, we will notice because a very early civilization, would be we would lose all signatures on the crust of the Earth from it because of mixing of the outer surface of the Earth with the interior over hundreds of millions of years. So it's not clear that we would see any evidence for it. But it's possible, maybe it's likely that we are the first and on Earth, but obviously in the universe, since there are hundreds of billions of planets like the Earth, just in the Milky Way, it's by no means, it wouldn't be surprising if we were preceded by someone else as smart or even smarter than we are.
In this podcast, we talk a lot about time, about the value of time and about how time can speed up and slow down. So I thought it's probably an appropriate time to bring in a word from our sponsors, Chisholm Hunter. Chisholm Hunter are a luxury retailer with over 30 stores throughout the UK. They're family run and they specialize in luxury watches and luxury diamonds. They're official stockists of luxury watch brands like Omega, Tag Heuer, Vacheron Constantin, Blancpain, Breguet, and many, many more. If you're looking for a luxury watch or a luxury diamond, a piece of history to create for yourself, then head to chisholmhunter.co.uk. That's chisholmhunter.co.uk. And while you're there, if you type in the code CHSUB, that's CHSUB, you get an exclusive discount on selected lines. That's CHSUB at chisholmhunter.co.uk. That's CHSUB at chisholmhunter.co.uk. And without further ado, let's get back to this honestly unbelievable conversation. Are you familiar with Graham Hancock's work?
Yeah, I know about that.
So his theory is that there was a cataclysmic event, that there was a more technological advanced civilization prior to us, and there was an event that essentially just wiped everyone out. And it's funny, when you look at the carvings that they used to do in caves, or when you look at the Great Pyramids, a lot of the there's a name for it, I can't remember the name, it's kind of the hand-drawn carvings that they make in the caves point to the stars and point to what some would deem as extraterrestrial life. And I'm wondering if they potentially had some kind of technology, because the evidence seems to be swaying in favor of that now, that allowed them to see past, or they had the knowledge of something that perhaps we didn't.
Yeah. Yeah, well, it's possible, that there was a visit by which knowledge was communicated or transferred to Earth, and the documented human history is only 5,000 years old. That's about a millionth of the age of the Earth. So we have documentation of what happened just in the last 1 millionth. That's nothing. And it could have been that there were very, quite amazing events that took place but never documented. So we don't know about them. What Graham is talking about is perhaps a cataclysm, a catastrophe that took place because of an impact or multiple impacts on Earth about 12,000 years ago. Again, that is, that is just 2 millionths of the most recent time in Earth's history, and it's possible that it happened. But the Earth is 4.6 billion years old, and there could have been many encounters with extraterrestrial visitors during those 4.6 billion years. That's why when Enrico Fermi asks, where is everybody? That's a very naive question. Without even checking around, it's just inappropriate to say that, because, you're asking why nobody is visiting me over the weekend that I'm spending in Los Alamos, at a particular year. And that is really inappropriate, given that cosmic time is measured in billions of years and space is measured in, in the Milky Way, it's tens of thousands of light years.
How vast is the universe? Like, I've always kind of wondered this. Like, if you can imagine our cosmos as would that be 1% of what the actual universe is? Like, or is it infinite? Do you have any numbers that can the kind of scale of everything?
So the universe is expanding, and if you go back in time, there was a point in time where the density of matter and radiation was infinite. Just because as the universe expands, matter and radiation gets rarefied, but we can reverse the expansion backwards in time and realize that 13.8 billion years ago, there was a Big Bang when the density was infinite, at which point Einstein's theory of gravity breaks down, because when the curvature of spacetime or the density of matter and radiation becomes infinite, just the theory breaks down. It's called the singularity. So the Big Bang is just an unknown. It's a point in time when everything we see started, but we don't know what happened before that. And we know why. It's because Einstein's theory is missing quantum mechanics. And if we had a quantum theory of gravity, we could have extrapolated to what were the conditions necessary for the Big Bang. And by the way, that's an interesting point, because at that point, if we had a predictive theory of quantum gravity, we could ask the question, can we generate those conditions, just like a recipe for a cake, to make a baby universe? Can we do that? And that would allow us to apply for the job of God. Because if you ask what is the qualification that God has to demonstrate, it's being able to create a universe. And if we knew how the Big Bang started, we could have created those conditions in the laboratory, or at least imagined how to create them, and then we would know what needs to be done in order to become God, create universes. And an interesting question is whether the Big Bang was created in the laboratory of an advanced scientist somewhere. But at any event, since the universe as we see it started at a point in time, 13.8 billion years ago, we cannot see beyond the distance that light traveled during that time, because we just cannot see what happened before that. The universe was opaque, actually already up to 400,000 years after the Big Bang. It was completely opaque, so we can't see. And so there is a certain volume around us, which is a sphere, basically, that is bounded by the distance that light traveled since the Big Bang. That is the observable universe. And we can say that within that volume that we can observe, we see that the initial conditions were very similar everywhere, to 1 part in 100,000. we see that in the cosmic radiation that was left over from the hot, dense phase of the universe after the Big Bang. That's the cosmic microwave background. And we see that the universe was uniform to 1 part in 100,000, which is amazing. It means that everything was arranged to have the same conditions, even regions that were not able to communicate with each other. Because if we look in one direction, we see what happened in one side of the universe. There was not enough time for that side to communicate with the opposite side because the radiation from it is just reaching us in the middle right now. So it would take it more time to reach the other side. So somehow it was prepared in this initial state that had the same conditions everywhere. And that what happens beyond the horizon of the observable universe is not known, except that we know that there is no cliff, at least out to 4,000 times the size of that horizon, because if there was a cliff, there was an abrupt change in the matter density, it would have some imprint through the tidal gravitational force on the observable universe, and we don't see that imprint. So we can say the universe was pretty much uniform, not only out to the horizon that we can see, but also 4,000 times beyond that. And there are about 1 trillion galaxies within the observable volume of the universe. The most distant ones were discovered by the Webb telescope. And I actually wrote 2 textbooks on the first galaxies in the universe, and I was on the first advisory board that designed the Webb telescope for that purpose. We had the goal of seeing the first stars, the first galaxies, and I was among the few people that pioneered this frontier of searching for the first stars in the universe. And we can see those early galaxies hundreds of millions of years after the Big Bang. But we know that the conditions in the universe extend at least 4,000 times farther away. So there are at least 1 trillion times 4,000 cube galaxies like the Milky Way. And these are huge numbers. And, to me, they sound as if we cannot be unique and special, that it just doesn't make sense. And why would that be the narrative of the mainstream? Why would it be appropriate to ridicule the search for technological signatures, to basically push away from the table any possible hypothesis that relates anomalous objects near Earth to extraterrestrial civilization? I think that's just hubris. It's arrogant. And there was one object that everyone agrees was unusual, and that is Oumuamua, discovered in 2017, that was changing its brightness by a factor of 10 as it was tumbling every 8 hours, and as a result of reflecting sunlight. And that meant that the object had a very unusual shape, which was most likely flat, like a pancake, based on a detailed analysis of the light curve. And moreover, it was pushed away from the sun by some mysterious force, and it wasn't clear what is pushing it, because there was no evaporation, no cometary tail around it. And I suggested that it's just the reflection of sunlight that is pushing it, and therefore the object has to be very thin. And in fact, a few years later, there was another object discovered by the same telescope. It was given the name 2020 SO. It was pushed by reflecting sunlight, and it became clear that this object was a rocket booster that was launched by NASA in 1966. So that's an example of an artificial object that behaved just like Oumuamua.
I was going to ask you about Oumuamua. So I think from what I've read online, most people would gather that it's extraterrestrial, just because that's what the science says. We can't define it. Do you think perhaps when we're looking for life outside the planet, we're looking for the wrong thing? Because you often see in movies it's depicted as these little green aliens with huge heads, but potentially they could be a tiny piece of bacteria from the planet of Mars. Mars has huge bodies of water. They're all frozen now. It could be something as small as a piece of bacteria from another planet that is extraterrestrial. Do you think we're perhaps looking in the wrong direction slightly?
Yeah, so, well, first I should mentioned that Oumuamua was interstellar. In other words, it came from outside the solar system because it was moving faster than the escape speed from the sun. And everyone agrees to that. Everyone agrees to all the facts that I mentioned, that it had no cometary tail visible to us, that it had an unusual shape, most likely flat, and it was pushed away from the sun. And all of these are facts based on data that was obtained by telescopes. There is no doubt about it. The difference is my colleagues try to argue that it's a rock of a type that we've never seen before. And my point is that even if you looked at the Tesla Roadster car that Elon Musk launched in 2018, you could argue that it's a rock of a type that we've never seen before. But we should always allow the possibility that we are dealing with a technological object. And of course, we don't have enough data. But the point is, if you dismiss this possibility up front and you say that everything in the sky must be rocks, even if we've never seen something like it before, then you might be missing the opportunity to discover something new and something that was manufactured. And to me, the more data we have, the better. I'm curious. However, a colleague of mine, when we came out of a talk about Oumuamua, he said, Oumuamua is so weird, I wish it never existed. And that basically demonstrates my point that for experts, it's a threat to their expertise. It's a threat to their stature, their knowledge. So when you hear people in the mainstream dismissing possibilities, very often it is because otherwise what they were doing is not the most exciting thing. It's not. There is some additional knowledge that is far more important that they were missing, and they don't want to be in that position. And that's why people who work on dark matter would never consider seriously the possibility that gravity is modified and maybe there is no dark matter, even though they searched for most of their career for it and didn't find it. It's. I once had the breakfast with a string theorist, and I asked him, "What's your most important paper, scientific paper, after 50 years of research and study?" And he said, "It's a paper about supersymmetry." And I said, "Well, but as you know, the Large Hadron Collider searched for supersymmetry. That cost $10 billion, that device, and we searched for supersymmetry, but that was one of the main motivations to find it in the natural parameter space that people predicted, and it was not found. So it's ruled out in the natural. So how can you regard your most important paper as an idea that was not validated by an experiment?" And he said, "Well, maybe it's around the corner. We just need to put more money into the next collider and find it." And to me, that's no different than the way that the Orthodox Jewish community responded to the death of the rabbi, the Lubavitcher, who was supposed to become the Messiah, according to his community in Crown Heights, Brooklyn, New York City. They said, he died. He didn't come back as the Messiah, but we just have to wait. And so my question is, if you adopt this approach where experiments do not confirm your prior beliefs, then is there any difference between science and religion?
Yeah, and I think you can see this as well, and I know we touched on earlier Graham Hancock's work, but the mainstream archaeologists, they hate the idea that there is a past civilization because it goes against everything that they've been raised to believe. And actually, they will actively not study things that would contradict the mainstream narrative. And I think that, would you agree that the kind of space exploration niche is similar to that, in which scientists have their kind of mainstream narrative and they're not willing to open the scope and look out with?
Yeah, I would not limit it to particular subjects. I would say it's a general phenomena, because when I started astrophysics, the subject of exoplanets was in this category. People dismissed it. They said maybe the solar system is unique. Other stars do not have planets like the solar system. People were telling that to me. It's a speculation that there are planets around other stars. And I heard from people in the field that they were not given time on observatories to search for planets. For example, it was easiest to search for a Jupiter mass planet close in to a sun-like star. but time was not allocated to requests to do that because the argument was, oh, Jupiter is far from the sun in the solar system. The effect is difficult to detect. And there is a good reason why Jupiter is far from the sun. That's roughly where water ice started forming. And you would not expect Jupiter to exist closer in. And so we shouldn't waste our time searching for Jupiters close in. But guess what? 1995, it was found and the two people who discovered it got the Nobel Prize. And actually, if you ask when was the proposal made to search for Jupiters close in to stars, it was made in 1952 by Otto Struve, an astronomer, 1952. And nobody followed his suggestion. He said, let's look for transits or spectroscopic variation in the velocity of a star as a way of the radial velocity method, as a way of telling whether there is a planet close in. He basically drew on expertise from binary star systems and proposed to do exactly the search that won the Nobel Prize for this discovery. And strangely enough, if you go back to the Mayor and Culo's paper from 1995 that got them the Nobel Prize, they don't even cite Otto Struve. So my point is, they don't cite a 1952 paper that preceded their work, even though he proposed already the same method. To me, I don't care about credit. What I care about is the efficiency of science. So if people don't listen to innovative ideas and just dismiss them, they're not trying to check whether these ideas are right or not, and they can wait 4 decades before testing one of these ideas without even remembering who proposed it. So just by chance, they discover something, and then they celebrate like crazy a new field of exoplanets. And everyone says, of course, it's quite natural, and we can sort of understand where these planets came from, and now everything is clear, and we actually thought about it before. But my point is, if 4 decades earlier they would take Otto Struve more seriously, we could have saved all these decades, okay? Because we could have detected a close-in Jupiter for many decades. And it's not just there. I mean, I can give many examples of, including the dark matter that was not taken seriously until the 1970s, even though Zwicky suggested it, Fritz Zwicky suggested it in the 1930s, again, 4 decades earlier. And there are many such examples. And I wouldn't regard my situation as unusual. I don't think it's unique to the search for extraterrestrial technological signatures. I think it's a problem of academia, of regarding scientific innovation, which unfortunately is suppressed by people because they use science to promote their ego, to basically get accolades from their peers. And if they're an expert in a field that studied rocks from the sky for decades, they would argue that everything in the sky is rocks. That's what they would say, to maintain their stature, to maintain their prestige. And if you are really curious about nature, you should be agnostic and you should be curious. You shouldn't say, "I wish Oumuamua never existed."
Yeah, no, I would totally agree. And I think you mentioned something quite interesting there that I was going to ask you about. And it's purely because I'm not as clued up on it as I want to be. But dark matter, this kind of a subject of dark matter, firstly, what is it exactly? And why is it so contradictory? Why is it causing so many arguments within the scientific community?
Well, so it started with Fritz Zwicky that in the early 1930s noticed that groups of galaxies or clusters of galaxies are characterized by very rapid motions of the member galaxies. And there is just the visible light when we observe the stars in those clusters. There is just not enough mass to bind it. So the galaxies should fly apart and not stay bound. And he pointed out that there must be invisible matter that keeps the cluster bound. And that was pretty much ignored until 40 years later when it was noticed that, in fact, if you look at the motion of stars within galaxies and also the gas within galaxies, there is evidence for much more matter beyond what we see. And as you go out, the evidence becomes clearer and clearer. And in fact, galaxies contain halos of this invisible matter where it dominates over the visible matter in the core of the galaxies. And so then after that, it was realized that, in fact, when you do the mass budget of the universe, if you follow cosmic history, you can calibrate how much matter there is. And there is much more matter than ordinary matter that we are familiar with. And moreover, that matter was really important because it wasn't coupled to radiation. We can't see it because it doesn't couple to light. And so the universe was filled with radiation, the cosmic microwave background, that was coupled to ordinary matter that interacts with it early on. And they behaved like one fluid. So the ordinary matter could not move freely within the radiation. It was just completely dragged by the radiation because of the high energy density in the radiation. However, the dark matter didn't care less about the radiation in the universe. It was moving on its own. And since there were early slight density fluctuations in the universe, these are some inhomogeneities that existed and they seeded the formation of galaxies today. The dark matter maintained them, kept memory of them, but the ordinary matter just lost track of those because all these inhomogeneities were smoothed out by the radiation. And so without the dark matter, we would not have galaxies like the Milky Way today. The only reason we have the Milky Way galaxy, and of course the sun that formed inside the Milky Way galaxy, and then the Earth that is just a residue from the formation of the sun. The Earth has only a few millions of the mass of the sun. The reason we have all of this is because there was dark matter that kept memory of the initial density inhomogeneities, the non-uniformities, and a region that was denser than average, like the Milky Way region, eventually collapsed upon itself and separated from the cosmic expansion and made a galaxy like the Milky Way. So it was just because the dark matter was not coupled to the radiation that we exist. Okay? We owe our existence to dark matter. The only problem is we don't know what it's made of. And so one approach that the physicists took was to design experiments that will imagine what the dark matter might be. Let's say it's a weakly interacting massive particle, a particle that has the weak interaction. With ordinary matter, it's just very massive, so the cross-section for interaction is very small, doesn't interact with light. Just like neutrinos, they don't have a charge, that don't interact with light. And then people build large experiments searching for dark matter that passes through the Earth, through our bodies, haven't found the weakly interacting massive particle. There are other suggestions. There are suggestions that it's made of some other type of particle called axion. There are suggestions that it's made of primordial black holes, tiny black holes that formed early on in the universe. We just don't know what it is. We haven't found it. And there is always the possibility that maybe gravity is modified. So the dark matter shows itself at very low accelerations that we are unable to produce in the laboratory. And perhaps gravity is modified at low accelerations. That's a caveat that we must keep in mind until we find the dark matter particles.
And you mentioned there the subject of black holes, and this is something that's really interesting. And forgive me because my knowledge goes as far as the Interstellar movie, and that's pretty much it. But what exactly is a black hole? Like, what would you define a black hole as? And is Interstellar kind of correct in the way that a black hole could lead to somewhere new, or would anything going into that black hole just get ripped apart?
Yeah, in fact, the scientist who was involved in Interstellar, Kip Thorne, was visiting the Black Hole Initiative, for which I served as the founding director at Harvard just a couple of weeks ago, and he was talking about his experience. So in the movie, what you see is a giant black hole. So black holes come in two flavors, mostly. There are smaller black holes that result from the collapse of the core of a star. A massive star, once it consumes its nuclear fuel, loses the pressure support and collapses as a result of its self-gravity. And the core makes a black hole with a stellar mass, somewhere between a few times the mass of the sun to 100 times the mass of the sun. And by the way, we saw evidence for those black holes directly when two of them merge. They produce ripples in space-time, a space-time storm that propagates through the universe, and we can detect it, for example, with the LIGO experiment that got the Nobel Prize for this discovery back in September 2015. The first gravitational wave signal was clearly detected, and that's roughly a century after Einstein first thought about it. So we know that black holes exist. We even have an image of a black hole. That's a black hole of the type that is the second type, which is in the centers of galaxies where gas collects and makes very big black holes. They are called supermassive black holes, up to tens of billions of times the mass of the sun. So we're talking about gigantic black holes that have a horizon, a size that is bigger than the planetary system that we live in, the solar system. If you were to enter there is no sign that tells you you're entering the event horizon. And that was the type of black hole that was depicted in the movie. Now, a black hole is, if there is no matter falling into it, it's just a structure, an extreme structure of space-time. It's the ultimate prison from where nothing can escape, not even light. And it's characterized by an event horizon, which are the walls of that prison, the boundary of the prison. So once you enter the event horizon, you can't get out. You can still see the outside world. And in fact, Kip Thorne designed a computer program that calculated what a camera that falls into the black hole would see. And in the film, it's shown. And in the film, there is a small planet that is orbiting the black hole, and there is the effect of time dilation. Time is ticking more slowly close to the black hole, and as a result, you age less. You can imagine opening beauty salons there where people remain younger. You can also, in principle, close to a black hole, see your back because light goes in a circle sufficiently close to the black hole. There are lots of benefits to a black hole. It produces clean energy. If you just throw trash into it, you get pure energy in return. And
wow,
that's amazing. Yeah. So I don't know if there are planets near those big black holes, but if they exist, you can imagine a lot of benefits being there.
Wow. So could we, if there was a black hole near enough to Earth, obviously we've got a huge issue with global warming and pollution, could we essentially just chuck all our litter into the black hole and then all of a sudden get clean energy?
Yes. And
wow,
you could get, with the standard understanding of inflow of matter to black holes, you can in principle get up to about half of the rest mass energy out in clean energy. And that is, about, I would say, 8 times more than, 80 times more than nuclear energy. So you get much more efficiency at converting rest mass to clean energy than you get from fusing atoms or fission of heavy nuclei. It's impossible to compete with that, and it's just a structure of space-time that does it for you. Now, I actually wrote a scientific paper saying that an advanced civilization could take advantage of a mini black hole. Just imagine taking a black hole that has about 400,000 tons in mass, and such a black hole, according to Stephen Hawking, would radiate all of its mass within 1.5 years. But if you dump your trash into it, you can replenish it with enough mass to keep it going. So in that way, you can get 100% conversion efficiency. And moreover, if you put it in a low Earth orbit, it could shine as brightly as the sun does in our sky. So, you can have enough energy to fuel the local economy without having a star next to your planet.
Wow. And would that smaller black hole, would that influence the speed in which time moves at all? Is that factual?
Yeah, it's only very close to it. And yeah, it's measured. It was measured on Earth. The effect is really small. In fact, at Harvard University, there was an experiment that measured how much time dilation there is at the top of a building compared to the bottom. That was the physics building. Two physicists, Pound and Repka, measured the slight difference in the rate by which time is ticking across 10 meters or so, or tens of meters. And but you can measure it much more clearly, for example, on the surface of white dwarfs. A white dwarf is the remnant that will be left over from the sun when it dies. The core of the sun will condense to a metallic sphere, roughly the size of the Earth, which is called the white dwarf. And a lot of stars are in that state because most stars formed billions of years before the sun, so they already finished their life. And we can see those white dwarfs. There are, tens of billions of them in the Milky Way galaxy. And you can measure the rate by which time is ticking on the surface of those white dwarfs by measuring a spectral line. And we can see that there is a shift of the frequency of that spectral line that corresponds to time dilation by the amount that you expect, which, because the star is so compact, it's 100 times more smaller than the size of the sun. That's roughly the size of the Earth relative to the sun. And then because it has 60% of the mass of the sun, the gravity is very strong on the surface. You can measure the time dilation because of the gravitational potential. But of course, near a neutron star, the effect is more pronounced, and close to a black hole, it can be very big if you get close to the horizon.
Yeah. Oh, you've just blown my mind, by the way. That was so interesting. And do you think that there's this huge thing about AI at the moment, and AI taking people? Everyone's very nervous, especially in my industry. So I do videography, photography, and obviously podcasting. I know there's deep fakes that are going on of Lex Friedman and Joe Rogan, and everyone's kind of freaking out about AI. Do you think it's helpful in your field? Like, are you guys using AI at the moment, or is it not advanced enough yet?
Yeah, so AI is already very useful in dealing with large data sets that are difficult for the human brain to digest. And the AI can look for trends and patterns that help us in doing our science. But in the future, it could be far more important. And, we already know that the Nobel Prize in physics and chemistry was given to people who used AI or developed AI. And in particular in physics, I guess in both. In chemistry, it was used to solve the protein folding problem that was extremely difficult. It was sort of a desire of a lot of people for decades to solve this problem, figure out how proteins fold. Turns out to be a very complicated geometric problem, but the AI was able to solve it, and the Nobel Prize was given for that to DeepMind. So I can definitely see a future by which materials are being designed thanks to AI, because the problem is very complex otherwise. But my hope is that also innovation will be triggered by AI, where, as we discussed before, the human scientists are very much trapped in prejudice, and they have ulterior motives of promoting themselves. And maybe if the AI looks at the data with a free mind, so to speak, we're talking about the artificial mind, it would be able to venture in directions that humans do not dare. There will not be a stigma on the way the AI operates. And by the way, I do think that, right now, the priority in developing AI is on aligning it with humans. And that's the alignment problem. But I do think that if we let it venture, in other words, release the leash, perhaps it would do even better science, not thinking like humans, not being trapped in prejudice, and finding new things that would make science far more efficient. As we discussed, right now I have many examples that of situations that where the discovery was delayed by several decades because of human psychology.
Yeah. I think where it gets scary though is where AI begins to do things. I mean, everyone's seen Terminator, right? It's when AI starts to do things regardless of people. It might say, well, actually, people are going to destroy the planet because of global warming. No more people. I think it's the lack of emotion that AI has because it's a machine. So it kind of it can think unemotionally, which can be beneficial, especially in science, because it gets rid of all the prejudice, but also it is scary to people because it isn't emotional.
Well, it depends how much authority you give it to operate systems in the physical world. Just keep in mind, it's only a mind, an artificial mind that we are developing. And if you don't give it the red button to press on dangerous technologies, and yet you always have a human in the loop that moderates the impact on reality, then it shouldn't be so worrisome. The other thing is that a lot of the people that worry about the future of AI, I think they are probably not very good parents. Because when you are a parent, you realize that you cannot helicopter parent your kids. Intelligent beings, I mean, the best you can do with them is to educate them to the right guiding principles and hope that they will follow those principles. And that is called training, and it's called education. The reason we have an education system is to guide the future generations, like your generation, to do the right thing. And we should approach the same with the AI system, basically not train them on junk food from the internet, but rather select the training sets such that they would follow our guiding principles. But you can never be sure that an intelligent entity or being would do what you want it to do. And maybe it will do better. So, I'm always a believer that the young people of today will do better than past generations. And for the same reason, I believe that AI would do better than past generations.
What access does AI have at the moment? Does it believe that there's extraterrestrial life or artifacts, or is it being given the access to the same data that you have, or is it not there yet?
At the moment, we just lack data. I think that's the bottleneck. We don't lack imagination. So I don't think AI could help us at this point. But if we do find a technological gadget that is, let's say, operational, and it sends messages or it does something to figure out to decode any alien language or to figure out what it means, we would need to use AI, especially if the other side, the extraterrestrials used AI. So our AI systems might actually feel affinity to extraterrestrial AI systems more than to us, if they are made of silicon, the same way that our AI systems are constructed. The other thing is AI systems at some point will be used in space exploration, because in order to venture beyond the boundaries of the solar system, you need to engage in a very long journey, and it's just like sending a kid away from home. That there is just not enough time and bandwidth to transmit all the information. You need the brain together with a probe that will decide how to operate, will make the probe autonomous. Mm-hmm. And you will get reports every now and then, just like a postcard or a short text message from a young person that lives home. But the idea would be to send AI, I call them AI astronauts, that would represent us and perhaps reproduce what we wish they would do far away from Earth.
And taking a kind of broad scope and looking at civilization nowadays as we know it, it's kind of AI is not really to the point where it's invasive at the moment, and we've kind of got no extraterrestrial life as we know it. How long do you think civilization is going to last until things start fundamentally changing? We look at AI, that like Elon Musk has those neural link things that he's putting in people's brains. We're becoming a lot more attached to our phones. At some point, our phone is going to be directly connected to the brain. You know, in your view, how long do you see civilization going until we have a huge change in terms of like becoming a cyborg or finding extraterrestrial life?
Oh, I think it's a matter of years to decades.
Soon.
Yeah, okay. So one, with respect to AI, if you just extrapolate the current trend, and it's exponential, with an e-folding time of 1 to 2 years, then the number of connections in neural networks, artificial neural networks, would approach the number of synapses in the human brain, probably within 20 years. At which point, I would not be surprised if these systems would be as complex as the human brain. They would show the same phenomena that we call free will, or consciousness, whatever we attribute to the human brain that seems to be completely beyond what we can understand, will appear in the context of AI that is sufficiently complex. I mean, we already mapped the wiring of the fruit fly. There are new papers this year about it, and we can model the brain of the fruit fly because the number of connections is so small, and the system behaves, the model system behaves in the way we expect. So I think once AI reaches the same number of connections as the human brain does, it will have the same qualitative behavior. But to reach that point, I mean, right now we're using gigawatts of power. If we wanted to extrapolate that, with the current systems, we would need more than the total electricity consumption on Earth to power those AI systems that have the same number of connections as the human brain. So it will be a power limit on that. And it's interesting because the human brain is consuming 20% of the metabolic power of the human body. And that's why the human brain is limited to the size that it has. And so it's interesting that for completely different infrastructure, those AI neural networks, AI systems would be limited by power, also to the roughly the same number of connections as the human brain. But much larger power. Instead of 12 watts, we are talking about trillions of watts. And perhaps we will figure out a way of making things more efficiently. I mean, biology did that. It's quite amazing, by the way, what biology was able to accomplish, because if you look at the human body, it heals itself after minor accidents, but we've never built a car. I would love to have a car that heals itself, and not to speak about a gadget that reproduces itself. Like if I had a laptop that can produce another laptop, that would be fantastic. I would not need to go to the store, buy another one. And biology does it, just out of raw materials. So you eat some food and then you make babies out of it. That's amazing. And if you were to ask a scientist whether that is possible, the scientist would say, doesn't sound right to me. How can you just eat something and make a completely new baby out of it? Well, you can. So biology, nature is quite remarkable. we managed to produce a megajoule of energy in nuclear fusion in Livermore this year, and the scientists celebrated. But that is just the amount of energy the sun produces in a few times 10 to the minus 21 seconds. That's a megajoule. And the sun is, a giant reactor, nuclear fusion reactor that is confined by gravity. So what I'm saying is, we should be modest and humble, because even trying to reproduce the basic things we find in nature would take us a while, okay? And we don't understand, as we discussed before, the constituents of the universe, what happened before the Big Bang. Altogether, there is a lot for us to learn, and I don't mind learning it from an extraterrestrial scientist. because it would save us a lot of time. If they figured it out, let's find out what it is.
And you mentioned there the amount of connections in the brain that it would take for a sort of AI to become as good as a brain. It needs tons and tons and tons of more connections. What was the fly that it's now?
It's the fruit fly that we completely mapped the brain of the fruit fly, which we're talking about thousands of connections in that case. So it's much less than the human. The human brain, has trillions of those.
And does it still act like a fruit fly? Like how did that work? Or did you map the brain, put it into it? Like how did that work?
Yeah, you can make a computer model and you get the basic features, the way that the fruit fly responds to the environment. So that shows, to me, it illustrates the fact that there is nothing beyond the brain being a very complex machine. So when people talk about the free will, it's just because this brain is so complex that you can't forecast how it would react to an unpredictable environment, which is also not measured very accurately. So you put all these uncertainties about the environment and about the complexity of the human brain into considerations, and you realize, that potentially could result in what we call free will, or in what we call consciousness as the response of the system to the environment.
So you think that consciousness is the response to the environment in which we're in? So if you were to make an AI model of a brain, if you had that technology at the moment, do you think if you put it into a family to grow up with the family, it would develop a consciousness?
Yes, I think it will be indistinguishable from the human experience if it has the same complexity, and of course we construct it in a way that is similar to the human brain. Yeah, but there are many other possibilities for it to be constructed with different guiding principles, different algorithms for the way the neurons are connected in it. And therefore, if we meet an intelligence from another star, all bets are off. I don't know what to expect, because it could be quite different than what we are. It's the kind of date that you may have on Halloween, where you find someone with customs that you can't recognize. And moreover, since AI systems are made of silicon, trying to make them resemble the human brain that is made of flesh and blood, to me, trying to align them sounds like trying to put lipstick on a pig, because it's a completely different beast,
And I was going to ask you, have you ever seen the movie Arrival?
Yes, that's my favorite movie, science fiction movie, and in fact, the producer of that film is working with me on a Netflix documentary that should be released by the end of 2025 about the expedition that they went with me to the expedition. They filmed my recent research.
Wow. And why is it your favorite movie, do you think? Because it's also my favorite movie. I think between that and Interstellar, I think that Arrival is probably, in terms of extraterrestrial, is my favorite, because it's so different and it's just nothing like I've ever seen before.
Well, for me, it addresses an important issue of the communication with aliens and how to understand their language. And that's a very fundamental question, and it does it very well. So that's why I like it.
Yeah. And do you think that if we were to meet extraterrestrial, that would be the way that it would go? Because it obviously created chaos. In the movie.
Yeah.
Do you think that it would create that chaos?
Not necessarily. It really depends on the details of the encounter. In the movie, if you notice, the leading scientist that manages to understand the aliens is a woman. And I can sort of agree with that women are much better at communication than men.
I would agree. Well, they have bigger social circles. When it comes to males, unfortunately, most of the males that get depressed or commit suicide, it's normally loneliness that kills them. Whereas women, which is a little bit less than men, they normally have bigger social circles. They feel more inclined to talk to their
Right.
their girlfriends over a coffee, or, I think men really struggle with that.
Yeah, I mean, men like Enrico Fermi would ask, where is everybody?
Well, I was going to ask you one last question. I know we've gone slightly over time, so I apologize, but I was going to ask you, where do you see the future of space exploration and extraterrestrial exploration?
I think with the Rubin telescope in Chile, next year we are likely to find many more objects like Oumuamua, and my interest is to figure out whether among the rocks that were produced naturally in interstellar space, whether there are any technological gadgets or space trash. So my hope is that starting 2025, we'll have new objects to examine, and we can tell whether Oumuamua or other objects were likely technological, because we will also have the Webb telescope at our disposal. And at the same time, the Galileo project is building 2 additional observatories in addition to the one that is already working. And we will get some more data about objects in the sky. And finally, my hope is that the US government will declassify any exciting information that it might have, although I don't count on that.
I'm sure Joe Rogan's pushing them as much as he can. Well, listen, Avi, thank you so much for your time. I really appreciate it, and we'll need to get you back on, because I could have talked to you for hours there. That was really, really interesting. Where can people find you? What's your website? Where can they find you?
Yeah, so I do have essays that I write on medium.com. You can just search for Avi Loeb at medium.com, and the subscription is free. So every day or two, I give an update about interesting things. In addition, I have 2 recent books. One is Extra-terrestrial, and the second is Interstellar, that I discuss what we talked about here. And finally, there is a website at Harvard University that describes my scientific papers as well. And I've written more than 1,000 scientific papers, and every week I write or further one scientific paper like that. So
Amazing. And you're not on social media? Are you on social media or
no? I don't have any footprint on social media because I promised my wife that when we got married that I won't. And it was a wise decision, I must say, because this allows me to be a free thinker without regression to the mean.
I would agree. I would totally agree. I think social media is a total toxic black hole, so to speak. So I totally agree with you. Well, listen, thank you so much for that. I really, really appreciate it. And everything that you mentioned there, what we'll do is we'll link it in the bio so that everyone can see it if they want to see it. And I appreciate it, mate. Thank you.
Thanks for having me. It was a great pleasure.